Yeah, thank you so much. That would have been my fun fact. It's amazing to be back here after a very long time. So I wanted to start this talk by saying something that I hope is a little bit provocative, and that there's kind of this chasm that exists between how the AI and machine learning community thinks about producing state-of-the-art models and how the human-centered AI community thinks about evaluating team performance. And what I'm going to try and demonstrate in this talk is that the reason that it's difficult to develop useful AI systems is because we collectively as a community are spending way too much time on the left-hand side over here, worried about state-of-the-art model metrics, and not enough time on the right-hand side over here thinking about evaluating human AI team performance in very comprehensive ways. So what does this look like in practice? I'm going to pick on IBM a little bit, right? This is a snapshot of a model leaderboard, and I've been in these meetings at IBM where we get super excited that the new generation of our Granite large language model is increasing performance on some kind of eval benchmark by 0.5%, 0.05%, whatever the metric is, right? They get very excited when they squeeze out more performance of these models. But that's not how we think in the HCAI community about building useful AI, right? This is, I think, Jessica just showed a slide that was almost exactly like this, right? The way we think about evaluating these systems is we want to look at some kind of task where there's an individual who's doing the task, maybe there's an AI system that can do the task by itself, and then we look at this joint human-AI performance. This paper, if you're not familiar, this is actually the slightly old version of the paper, was a survey of studies that evaluated AI systems in this fashion. They looked at this metric called synergy, which is just this ratio of what is the joint team performance over the sort of best individual performance, to try and understand how much better are things because a human and an AI are working together. And this is my favorite picture from this paper because it shows, same thing that we saw in the previous talk, it's all over the place, right? Just because you throw AI at people doesn't mean that they do a better job on some task. Sometimes they do, those are the studies on the right. Sometimes it's actually worse, that's the studies on the left. And a lot of the time it's in the middle. So it's like, is there really something going on or not? So in the rest of this talk, I want to cover these three things. Hopefully I can keep on time. The first one is going to be very, very brief. It's just how we in my team at IBM think about evaluating the joint human AI performance across a variety of tasks. The second one is I want to give some examples of systems that we've built to provide assistance across a lot of the different types of jobs that we have going on inside IBM. These are things like software engineering and product management and design. And really showing that there's a nuanced story about, is AI making things better for people doing these tasks? Is AI really being useful for people? And then the last part that I'll probably have to breeze through is sort of motivating ideas from mutual theory of mind as being a way to help AI systems become more useful to people. So the first part of this is really human-centered metrics for evaluating AI systems. This is the framework that we use. This is how we think about it. Wow, the emojis just got so weird. And in the last talk, this is probably a little bit of a contrast because we don't think of it in terms of a single metric, right? We think about it as measuring all the things. What are all the things? Well, some of the things have to do with the artifact itself. A lot of the situations that we look at have to do with creating some kind of artifact, like software engineers who are writing source code or product managers who are writing epics. So there's an artifact there, and you have to evaluate some kind of qualities of that artifact. But we also consider the work process, right? How much energy or effort are people putting into creating that artifact? How much time does it take them to create that artifact? And then we also care a lot about these human-centric measures. Do people feel like they have superpowers because they're working with AI, right? Maybe they feel more productive even if objectively it doesn't look like they're more productive, right? So this is kind of the framework that we use when we design studies and we think about what are the things that we want to measure. We try to come up with individual measures that cover the spectrum of categories here. So now let me talk about a couple projects that we've done that kind of speak to this idea of enhancing productivity with AI. The first one I want to talk about, this is an IBM product called watsonx Code Assistant. This is AI for software engineers. You're probably all familiar with this concept, right? This is AI that lives in your code editor, and it can do things like generate code for you or explain code. This is a product that was developed sort of mid to late 2023 as a prototype, deployed inside of IBM early 2024. So this is before all the vibe coding stuff happened. I need to give that historical context here. And when this was deployed inside of IBM, right, the product team had these questions about what is the impact of this tool on the productivity of our software engineers. So I worked with that team, and researchers of mine worked with that team to come up with a very comprehensive survey framework, right? Some of us heard about designing surveys this morning, to cover all the things, right? One of these, the one that they were very interested in was, what is the impact on productivity? The standpoint that we had to take in this study was looking at people's feelings of productivity. So we had a lot of questions asking them about how they felt Watson Code Assistant impacted their productivity. I'm going to skip right to the results and show you there were multiple measures that we had on this, and both of them kind of showed the same thing. On the left, we're seeing results from some semantic differential scales that show that people felt like it was making their work easier, of a better quality, and helped them work faster. On the right were a bunch of Likert scale kind of statements. Some of them are kind of correlated with the semantic differentials on the left. And one point I want to make about this slide is it's very easy to look at these numbers and sort of see overall this tool was having a net positive effect on productivity. But that effect didn't hold for everybody, right? Some of this highlighted portion, those orange and red boxes, some people weren't feeling those productivity benefits. So this is kind of a complicated story, right? Because if you're like an executive at IBM, you want to be able to make these really confident statements about, yeah, our tool increased productivity by, 50% or whatever that number is. But in reality, what we're finding is when you put out AI out there sort of in the wild, it sure can help some people, but it doesn't necessarily help everybody for everything they're trying to do. Next project I want to talk about, this is AI for designers. This is a tool that we built called Collaborative Canvas. If you're familiar with Mural or Miro, right, there's a virtual whiteboard, there's stickies that go on the whiteboard. We built this, before Mural AI existed because we were interested in how AI can help in group ideation processes. So the tool itself is, exactly what you would expect from your virtual canvas, except for these features that we added where you can prompt the AI to generate sticky notes for you, or you could select existing sticky notes and prompt it to sort of reformulate those things. And so that is amazing. Okay, that's why I sent you guys a PDF. So anyway, modulo the gobbledygook and the quotes about participants, I guess the highlighted portions are the important parts, right? Really, the point of this whole slide is we put this tool in front of designers, we had them use it, and we get mixed sort of feedback, right? On one side, designers felt like, yeah, there's a lot of potential benefits to this tool, like it can help provide missing expertise in brainstorming sessions, it could help people sort of overcome lulls in the brainstorming process when it gets quiet and everything. But also there's concerns, right? My favorite concern here is there's this facade of design thinking theater that, the AI is just generating a whole bunch of sticky notes, but it doesn't really have any meaning, right? It's just a bunch of random stuff, kind of like what I've got on my slide over here, right? So again, it's very hard to build useful AI. There's potential benefits, but there's also potential drawbacks. We did a separate study with Collaborative Canvas to look more deeply at the diversity of ideas that were produced in brainstorming groups, and the net result, I'll wave my hands a little bit on this one, is that when people were brainstorming with AI, the diversity of ideas produced in that group was diminished. So it looks like there's actually a negative effect of AI here, that maybe they should have just been brainstorming by themselves and they would have produced a more diverse set of ideas. But the irony of this one is people still gave positive feedback about working with the AI. I think this one was over a third of participants were saying like nice things about having AI in their group, even though there was kind of this detrimental outcome on the quantitative measure of idea diversity. Last one I want to talk about, this is AI for product managers. This is a project called the Epic Evaluator. So if you're not familiar, part of Agile methodology is to write these things called epics, which are basically stories of a new feature and how users are going to benefit from this new feature and how they're going to use it. You can think of this a little bit as like a boundary object between product managers and software engineers to communicate what the requirements are of the software that needs to be built. And one of the difficulties that product managers have is writing really good quality epics. So what we did is we built a tool that uses some of this LLM as a judge techniques to provide feedback on the epic and provide really detailed, actionable kinds of feedback across, the different categories of information that are present inside of the epic. And we did a study on this one, and of course the participants are giving more gobbledygook quotes here. But it's the same sort of situation, right? A lot of the product managers felt like this is really good to get feedback to make the quality of their epics better. But on the other hand, we discovered there were some concerns about it. Like, well, this is a tool that can be used to sort of score how good I'm doing writing epics. What if my manager sees that, right? That's not quite something that would come out if your measurement system only includes like quantitative evaluations of the quality of the epics. It's not looking at this broader sort of socio-technical context of how this tool might be adopted or not adopted in the organization because people are concerned about like being seen using the AI or being seen not doing a good job on writing these epics. So last part of the talk, I think I got 3 minutes left. I want to talk a little bit about mutual theory of mind. I've heard some discussions earlier today about theory of mind, and you saw Kate's presentation. So this is kind of how we think about it. Wow, my text got so screwed up. We think about it in this way. This is sort of one framing that we have, is thinking of it as sort of a noun or as a destination. There's a couple of key ingredients to operationalizing mutual theory of mind. One is to have an explicit model. So for the AI, really explicit model. Human beings have mental models, right? That's just, they'll have them, they'll always have them. But for AI, we assert that there needs to be an explicit model of who that user is. Not this sort of implicit, oh, large language models kind of solve theory of mind tasks, therefore they have theory of mind. We assert that you got to write that stuff down. We also then recognize that if you've made your model explicit, you can write it down for the AI, you can make it visible to the human. And if you make it visible to the human, then they can go in and fix things and edit things that are sort of incorrect. So our hypothesis here is we can get human AI teams to achieve superior outcomes on some kind of task when they've established this mutual theory of mind, right? When users know how to effectively talk to the AI or effectively work with the AI, and when the AI knows about the user, what their goals are, what they're doing in the interface, and so on. So what does that look like in practice? It looks less like this, more slide funniness. Less like this where, you have a user asking a question like, what is a qubit? IBM quantum computing. And they get back this very technical response that's maybe not at their level. Because the AI doesn't know who is this user and what is their level of knowledge. It looks more like this. User asks what is a qubit, and they get back sort of an easier to understand explanation because we know that this is someone who is not like a quantum information scientist. So another quick thing that we've done is we've looked at the area of source code explanations and trying to tailor those to the individual and kind of their expertise level and how they process information, sort of different individual characteristics of people. And overall, I'll just wave my hands on this one a little bit. What we find is LLMs will tailor their language when they're given information about who their user is. We are starting to build a taxonomy of what this looks like. What are the different adaptations that the LLM is making, given different information they have about their users. And also the chart on the right is showing when users receive explanations that match their own needs, they're rated as being much more useful than when they receive explanations that are just untailored, sort of generic, or explanations that are going in the opposite direction, of sort of opposite of what they need. So the three takeaways here, one is we need more emphasis on these human-centered forms of evaluating AI systems, right? The target should not be, I'm optimizing my model for 0.0 whatever % improvement on some eval. The point should be, let's build useful AI that solves real user problems in real contexts. Second point here is, even when your evaluations show net performance increases or net productivity increases, whatever, there might still be pockets of users who don't experience those increases, and we need to think about how to reach them and how to design for them. And our hypothesis is, by understanding who those users are and what their needs are, we might be able to have more equitable outcomes in terms of productivity increase from AI. So with that, I also want to acknowledge a whole bunch of people. I flew through like many people's work and many years of research that we've been doing at IBM. I get to work with a great team. Most of them are listed on this slide. And thank you so much.
Does anyone have a question for the speaker?
Hi, Justin. I had a question about the third direction, the mutual theory of mind, and I was curious which direction was harder, like having users have a better theory of mind versus having the AI have a better theory of mind of users.
Yeah, that's a great question. I don't know if I think about it in terms of harder, but right now we have probably spent the most effort thinking about what does the AI need to know about the user that is useful? Because there's sort of this universe of information that you might know about an individual, but that's not necessarily all useful information for a given task. So that's why we're starting to sort of probe at what could the AI know about people, and how does that change the AI's behavior toward people, and is that sort of a useful behavioral change, right? Like in the example of code explanations, that's why we're evaluating at both of those levels. Like, we need to observe just what is the AI doing with this information, and also is that resulting in something that's useful in terms of the user's experience. I think on the human side, it's also like a huge problem of how do you help people have useful mental models of AI systems? I think there's a lot of talk about how to have people have like accurate models of AI systems, and I think that's sort of the wrong direction, right? And the example I like to give on that is, I can go into great detail about how the transformer architecture works and how an LLM is sort of predicting the next most probable token and yada, yada, yada. But that doesn't tell you how to use something like ChatGPT effectively, right? Just because you know it's predicting the next token doesn't tell you about effective prompting strategies, right? And so, yeah, we also, are doing research in that area of like, how do you communicate to users? Here's how to use this system effectively. But I think right now we're tending to focus more on that AI side.
Great. Let's thank our speaker one more time.
All right. Thank you, everyone.
And next up will be John Bogard, who's an assistant professor of organizational behavior at Washington University in St. Louis.
Zero time, Carnegie Mellon grad.